In this video, we're going to be talking about a kill volume and how you can use kill volumes inside of your games to make the player character die. All right, so just to show you what we're going to have by the end, if you go over here, we're going to jump inside of our kill volume, and you can see we have an explosion. We hear an explosion sound. We don't continue to fall, so we'll talk about how we can disable the character movement. We're also going to reload the level like you just saw. There are other ways to handle death in games, like you could respawn the player instead of reloading the whole level. We're just going to do the simplest version of all this so you can custom tailor it to the game that you want to make, but this is what we're going to have by the end, just to give you a little sneak preview as we work through it in a lot more detail. So like this. There we go. I will tell you that I'm working off the previous mechanics that we've been building and the side scroller mechanics that we have already done. So if I hit play, you can see what I have here. We just have a character that runs back and forth and jumps, and that's pretty much it. Really, you can use the same logic in this video with any blueprint character. We're going to put some logic inside of the character pawn inside the blueprint. So just know that whatever you're using, if you're using the third person default, if you're using a first person, whatever, the logic is going to be the same. But later on when we do casting, you will need to specify your blueprint character. So I'll talk more about that later, but just to let you know, if you want to follow along exactly, you can go through the previous tutorials that show how to set this up. But if you want to do this on your own characters, that's fine too. All right, so first let's start with the basics. All Unreal levels, at least as of now, come with something called a KillZ volume. So if you go into your world settings and you scroll down a little bit, you're going to see this KillZ. What this is this is a distance on the Z plane, so the up and down, where if any actors fall beneath this distance, so -1000 down here somewhere, then they will automatically be destroyed. So just to show you, I don't have any kill volumes on my level, but if I hit play over here and I fall, you see how my character is automatically destroyed? That's because this distance is set to -1000. So if you did not know that that exists already, you can actually come over here and you can change it. What if we put it at 0, right? You see how we almost instantly die? So you can actually change this if you like. You can make that much lower if you don't want to mess with it. Just be aware that that's something automatically that's happening. Additionally, we have something called a KillZ volume. If we were to go into our place actors panel, go to volumes, and then scroll down to KillZ like that, we can actually have a volume inside of our level somewhere that we can place. And then once we have that placed, we can hit play, and it's pretty much doing the same thing. Our character walks into the volume and it's instantly destroyed. Now, both of these solutions are fine for destroying actors, but in a lot of games, you actually want full control over how your character dies. So for example, this is automatically destroying the character, right? When I hit play and I walk into it, the character is immediately gone. It's kind of a little whiplash because it takes us back to another camera because our player character doesn't really exist anymore. So we probably want to play some kind of animation, kind of pause the screen, fade out, adjust some gameplay things. We want full control over that. So instead of destroying the character with this kind of kill volume, so I'm going to delete that right there. Maybe it's important that our character is destroyed at some point, projectiles or whatever, if they go off into space. But I actually want to do this manually. So we're going to have some functionality on our character that defines what happens when the player dies. And we're going to have our own blueprint for a kill volume that we can drag around the level and call that death functionality on the player. Okay, so the first thing we're going to do is we're going to create a blueprint for a kill volume that does pretty much the default, except because we're calling it in blueprints, we can then add more functionality onto it. So I'm just going to create a blueprint down here. If you have any changes here, just save them. So Control S. And over here inside of our folder that we created, again, if you're working in a different project, just organize it how it makes sense for your project. I'm going to right click and create a new blueprint class. Now, this is something that we want to place in the scene. So anything that we want to place in the scene or the map in the world, and if it isn't something that needs to be possessed or controlled by the player, then we would make that an actor. So we're going to click that. Let's call this BP underscore kill volume. Anytime I make a new asset, I like to save it just in the off scenario that there's a crash. I don't have to remake it. Okay, so we save that, open it up. So inside of this blueprint, we don't have anything yet. So In order to create a volume to test for the player to enter to then run code, we're going to add some kind of collision. So click the add button and type in box and select box collision. All right, so this is going to be our box trigger where when the player enters inside, then it will detect and then it'll run some logic. So go ahead and compile, save. And we can always resize this inside the level. We don't need to worry about that in here. In order to add functionality to this, we're going to come over into our event graph. Something important to recognize, if you don't know this already, inside of blueprints, it's very easy to reference your own components inside of the blueprint graph. It's very difficult to find things that are outside of this blueprint, so other things inside of the level, for example. But in this case, if we want to test our own box collision, we can just drag and drop that in, right? And click and drag it. Because this event graph is attached to the same blueprint as our collision over here. So if we want to test anything in this collision, it's very easy. We can grab access to it. But if we want to do something to something else in the level, that's very difficult because we don't have local access to it. So just know that if you have a component that is local, just like if you're familiar with Unity, you can do a get component and find a component on your same object. We can very easily just get access to it like that, right? Just drag and drop. Now, what I want to do though is something a little bit different. I want to create an event, so I'm just going to get this out of the way, just select delete. If I click on box like this, components will give you access to some events depending on the component. But with our box collision, if we scroll down on the right side, we can look at all these events that are related to this component that we can add to our event graph. Now, an event will automatically get called if this event is triggered in code, and we don't have to worry about where it comes from. We just have to know that these events are triggered automatically and we receive the notification and it automatically runs that code if we add this event to our blueprint graph. Now you see there's a lot of default ones here. And what I'm looking for is something called onComponentBegin overlap. And if I click the check mark, again, I had to have box selected and I click the check mark. This adds a onBegin overlap with our box collision. So if anything overlaps, if I go back to my viewport, if anything overlaps our box collision, then we will run this code and then we can pull off of that. You can see there's other ones here. You might recognize the pattern if you have used Unity where it's on trigger enter, on trigger exit or whatever. It's the same kind of deal. In this case, a box collision will give us by default overlap type of functionality. It's not going to block unless we tell it to. We could go to collision and we could, set that if we like, right? But we want overlap by default. We want to pass through it and then call some code. So go back to our event graph, onComponentBegin overlap box. And the first thing we want to do is test if the other actor is the player. Now, this is kind of up to your gameplay, right? You could have a kill volume that would destroy projectiles, it would destroy the player, it would destroy enemies, whatever. Whatever you decide to filter here is up to you. To keep things simple, I'm going to only test for the player in this case, but you don't have to, right? You could detect other things. But the reason that I am detecting for the player is because I want to run specific death functionality. Now, you could also test for the player, and if it's not the player, then you still got an overlap and you could just destroy the other actor. But if it is the player, then run the player-specific code. It's totally up to you. But that's why I'm putting this code here. And I think understanding the why is really important at this point. When something overlaps this collision, we will drag off and we will run this event and we can say the other actor, and we have to test for the player, right? So first of all, we can very easily get the player by running something called getPlayerPawn. So if I right click, if I type getPlayer, you see we can automatically get some major components related to the player. You might see player character, you might see, which would probably actually still be fine, getPlayerPawn. So we can very easily find the player inside of our world. We can very easily get access to the player controller, which will come in handy a little bit later. Player camera manager, player state, etc. Anything related to the player, we can very easily get in blueprints. It's very hard to get access to other, non-player objects inside the world unless we set that up. All I need is getPlayerPawn. This will give me access to the currently controlled player pawn by this player. And since we have a single player game, it doesn't really matter. So get the player's active pawn. We drag off of that. We want to do a comparison. We want to say, is the other actor overlapping with this box the same as this player pawn? So we'll hit equals equals, so equal. So if we pull off of other actor, we can compare these two things. Now, I don't like how these wires are crossed, so this is kind of a minor, doesn't really matter. But if you hold Alt and you click these nodes right here, they will unconnect them. And I'm just going to reconnect them on the top and reconnect this on the bottom. Okay, so we're running a comparison here. And if the other actor is the same as the currently controlled player pawn, remember, this is very easy to get. And we drag off of that. If they're the same, and in order to do an if statement, we will call it a branch inside of Blueprint. So we're going to drag off and get the result of this. And we'll say branch. So type in branch. And you'll see that that'll automatically plug in. But I'm going to hold Alt and disconnect it again just to show you we could get this anywhere. We could just right click and type in branch. Doesn't matter. It wasn't really necessary. But this comparison between these two things, if they're the same, plug that into our condition for our branch. It will either return true, which will go off of that, or it will return false, which will go off of that. If it returns false, we could destroy the actor if we want. I'm not going to deal with that for now, but you could if you want to destroy enemies and destroy projectiles and whatnot. Either way, we need to execute this function, right? This is actually running the block, running the node. This is called our execution pin. So make sure you connect that. Plug in your comparison between your other actor and your get player pawn. Test it. If true, if this is our player, then do something. Now we could keep this really simple for now and just say destroy actor. And then if we destroy the actor, then it's kind of doing the same thing as our default kill volume. All right, so we're testing the player, and if it's true, we are destroying an actor. Now here's the thing. This sounds good, right? But what's really happening is when you call destroy actor without plugging in something into the target, like telling it what to destroy, it will destroy itself, which in this case is the kill volume, which it's not what we want. What we really want to do, since we're already getting the player pawn, let's just pull this all the way out and plug it into target because we want to destroy the player pawn, at least for now. We'll build the logic later. So we have our target, and if this looks a little bit messy, we can also do this. If you hover over the line and double click, drag that down. It's just called a reroute node, I believe. And we pull that out. So destroy the player pawn if it is the other actor. And then we can compile, save, hop back into our scene. Now we actually need to put our kill volume inside the scene in order to test this. So let's drag and drop like that. We'll resize it. So R, and we'll pull that out, like that, pull that up. We'll save our scene, hit play. Okay, so we're in play mode. If we go forward, it destroys our character just like our default kill Z volume. So, you know, we're doing the default, but at least we have the code set up so that then if we want to add specific functionality or if we want to test and filter out, we can. And this is a good setup for building into our final kill volume. Okay, so far we have our kill volume that destroys the actor just like we would normally do inside of our game with the default one. But now we want to add the additional functionality so that instead of destroying the actor, we want to trigger a death event. So potentially we could play animations, we could lock input, we could trigger some sound effects, and so forth. So that's what we want to set up here. So to do that, we want to be able to call a death event on the player. So here's where it's going to be a little tricky. For me, my player character is going to be called BP underscore SS character. For you, you may be using a different Blueprint character. So if you're using the third person character or whatever, you need to put this inside of your character's code. But again, for me and in this series so far, I've been doing the SS character that we created. So in our character Blueprint, it's BP underscore SS character, what we're going to do is we're going to create a death event that we can call from another Blueprint. And there's a couple ways to do this, right? You could make a function, you can make an event. I'm going to show you the custom event one for now so that we don't have to get into the weirdness of functions quite yet. So I'm going to right click and type in custom event. And this add custom event node popped up, and then I hit enter. And then we're going to call this whatever this event is doing. So we'll say died, for example. So we'll put this over here. You can ignore the other stuff, that none of the other code is relevant to this particular tutorial. It's just from previous tutorials. And so we have our died event, and we can compile and save. Now, the interesting thing about this is that this event can be called from outside of this blueprint if we have access to the SS character blueprint right here. So the question is, how do we do that? I'm going to come back to my kill volume over here, and we're getting the player pawn at this point. We are testing our overlap. We are saying if it's true, this is the same character, then destroy this actor. Well, instead of destroying this actor, what I can do is I can test this get player pawn and say, is this particular player pawn a BP underscore SS character? And if it is, then I want to run an event that's inside of that event graph. So to do that, drag off of this and type cast to BP. And then just at this point, you put in the name of the blueprint character that you're working in. And so casting is just saying, I want to use this object as this specific type. And in this case, I'm testing to see when I try to use it as this type or convert it to this type, is it successful? And then I can pull off and say, yes, successful, do these things as this type. And if it's not successful, then I would pull off of this and do something if I want. So I'm just going to connect my execution node right here so that we'll just keep running these things. But at this point, if we get the player pawn and they match, and this player pawn, if I attempt to cast it to this specific blueprint, this specific kind of player pawn, and well, player character in this case, a character is a type of pawn, which is why it allows us to do this, then we can pull off of that and run something from the character, right? And so this node right here allows us to run events that are inside of this blueprint right here. So when we created a custom event, those are public, and we can actually come over here and pull off of as BPSS character, meaning we can run things on this blueprint, pull off and say died, call function died. And this, it's calling it a function. It's calling this custom event right here. Again, functions are a little bit different, which maybe we'll get to later, but for now I'm trying to keep it pretty simple. So if we cast to this type of blueprint, and we do that from our get player pawn, and from that, we use that as the type and call an event on that type, connect the execution node, then we can call this at the moment that we want. So this should call the died event on our SS character. So if I save, compile save, come back over here, any logic that we put here will then trigger. So we can test that out if we want. We can pull off and type print, and we can say died, and I'm going to compile save. And in this case, it's not actually going to destroy our actor. We're going to put more logic here. But if I minimize and I hit play, you see how we got the died up there in the top left. So we know that it's working. So this is how we can call an event on our blueprint character from a separate blueprint object in our level that we can just pull around and reuse. So at this point, we should think about what are the things that we want to do. For sure, I would want to disable the movement on the player, right? I don't want them to keep running after we hit the volume, right? Another thing is we probably don't want to be able to keep putting in input. We want to lock the input so we can't just like activate our jetpack or double jump after we've died. That wouldn't really make sense. And lastly, we may want to disable the visibility, and there's lots of ways to do this, but for me, I'm just going to disable the mesh component on my character. I think that'll be fine for now. Again, this could get more complicated if your character is more complicated. When I pull off of died, let's do this one at a time. I'm going to delete my print string. First thing I'm going to do is disable the movement on the character component. Now, anytime you have this character movement component as a part of your blueprint, you see this is a separate thing and you get a lot of information and functionality with that. One thing we can do is if we drag in a reference to our character movement, it's kind of like get component if this were Unity. We're just doing a local reference to our component on this blueprint object. Our character movement, if we pull off of that, we actually have the ability to disable movement down here. And as long as we give it a character movement component, we will disable the movement on that character component. In this case, it is the player character. So that's what we want. So we'll hook that up. Okay, the next thing that we want to do is you want to prevent the player from continuing to move around and jump and put in other inputs on their keyboard. So the other thing we can do is if we get access to the player controller, we can give it a target actor that it is potentially controlling and say, don't allow this actor to receive any more inputs. So anytime we have like the player controller or the player pawn or the game mode or anything like that, we can typically get access to it with a get method, and this will, find this in our scene. So you can see, there's a lot of stuff we can get right now, but I'm going to say get player controller. And our player controller is the representation of the player in our scene, and the player character is the character that our player controller is controlling. So we want to tell our player controller, pull off of that and say disable input, because our player controller is the thing that is sending inputs down. We call that possessing inside of Unreal. And we're not wanting to disable the player controller. Maybe you do want to disable the player controller. It's kind of up to you, like whether you want to allow the player to restart the scene after, while they're in the death state. It's kind of up to you, or you could do that automatically. In this case, I'm going to hold Alt and click. I'm going to plug the player controller into the player controller node, so that the target, if it says self here, it's the blueprint that this node is attached to. So I'm inside of the blueprint SS character. I want to disable the inputs on my character. That way I can still have inputs on my player controller. So like pause, menu, whatever. I can still keep those inputs inside of my player controller, but my character movement type of inputs on this SS character. So I'm going to connect my execution nodes, and this is saying, tell the player controller, right, plug that in, that this actor, this pawn, this character should no longer receive inputs. But if I did want to keep inputs, I'll keep those on my player controller. Now, I don't think I have those set up yet, but that's how you could separate that out. So after your character is dead or gone or whatever, you can still allow game-wide inputs, just not character-specific inputs. So kind of important there. Make sure this is plugged into the appropriate one. Again, you could disable all player inputs if you like, but I'm going to, plug that in the bottom and just disable the inputs on this character. So I will compile and save. The last thing we wanted to do is disable the visuals, and there's a lot of ways to do that. I'm just going to keep this real simple for now. For me, I'm just going to disable the visibility of the mesh. But in a larger game, you could actually play a death animation. So instead of disabling it instantly, like we're going to do, you could trigger an animation that would be a death event. Alternatively, you could also use like ragdoll physics or something if you want to be kind of fun with it. For me, I'm just going to disable the mesh just to keep things real simple. In this example, I'm going to drag in a reference to our mesh component. And off of that, we have the ability to disable the visibility. So say set visibility, this top one right here, set visibility, connect the execution node. And what this is going to do is I want to disable the visibility on this component, this target. And that's going to be our mesh that we dragged in, our character mesh. So if that's plugged in, the new visibility wants to be false, meaning we do not want a check mark here. Check would say true. So we want to turn on the visibility. Uncheck would be false. So we're going to keep that unchecked. If this had child components, we could check that as well. In this case, it doesn't really matter, so we'll just keep that default. So compile, save, come back into our scene and test it out. So this is working for us. Our character still exists in the scene, so we can do things. So we're just disabling the input and we are disabling the visibility. So for now, I think that'll cover the character functionality that we want, and we can continue to build our kill system off of that. Okay, so another thing that we want for our kill system is we want to reload the level once our character dies. So I'm going to show you how to do that from our character that we've been working with. So if you open that up. So what we want to do here is we're going to call the reload level, and we're going to call it directly inside of the character. Now, in a larger game, you probably want to do this inside the player controller. I'm just trying to keep the example very simple. But if you had a custom player controller that, we did as part of this example earlier, you could put this code in there, and that way you're not repeating code and having it in multiple places. But just to keep this example really clear and simple, I'm going to put it right here just so you can see it. Once we disable our character, we want to trigger a level reload sequence. So I'm going to pull off of set visibility. And what we're going to do is we're going to start fading the camera. We're going to wait, and then we're going to reload the level. Okay, so the first thing we need to do is we're going to do our camera fade. So I'm going to right click, and in order to do a camera fade, we need to get access to something called the Player Camera Manager. So I'm going to type that in, get Player Camera Manager right there. So we can easily get this from a different blueprint. We're going to pull off of this and type in Start Camera Fade, just like that. All right, so there's a few things that we need to set up. From alpha 0, so 0 is going to be transparent, to alpha 1, because we want to fade to black. So I'm going to change this to alpha to 1, like that. Now, our duration is a little interesting. We could actually put a number for our duration in here, but I think for me, it makes more sense to actually make this a variable. So again, this could exist on our player controller. I think that would be most appropriate later on, but again, for simplicity of example, we're just going to keep this here. But I'm going to do something for duration. I'm going to right click and I'm going to say promote to variable. And that's going to make a variable over here inside of our SS character, our side scroller character. Again, your character could be something different. It doesn't matter as long as you're putting this inside of a character blueprint. And I gave it a name duration. I'm going to call this death respawn duration. Okay, we'll keep that float. And if we want access to this inside the details panel, I'm going to click the little eyeball right there to make it public, and we can see it in the details for designer control if we want. I'm going to drag this down here, say get player camera manager right there. This should trigger the camera fade. We need to plug in the execution node like that, connect that. So this is our camera fade. Now the interesting thing here is because we have decided a death respawn duration, we can keep that consistent and reuse it in our delay node. So once we start our camera fade, we want to do a delay node. So let's pull off of our camera fade and say delay, hit enter. And we're going to wait. And the duration that we're going to wait is the same amount of time as our death respawn duration. So we want to make sure we complete our camera fade. It's going to take this amount of time. So I want to wait that same amount of time for it to finish. I'm going to select my death respawn duration and copy, paste. Or, alternatively, if I delete that, you could just drag in from over here this new variable that we created. Drag that in, say get, and plug that in. So we're not just putting in numbers in different places, we're reusing our numbers. We're gonna pull that over there. So we're gonna wait this amount of time, and now we want to reload our level. Now the code to do that is gonna look a little bit funky, but we want to reload our level and we need to give it a level name. Now we can easily get the current level's name through code. So we'll compile save first before we do this. We'll pull off of completed and we'll type in get current level name and whatever we return. And then after we get the current level name, we're not going to mess with the return value yet. We're going to say open level by name, this top one. Now, as long as we give it a level name, then it will open that level at this point after we've waited this amount of time. When we get our current level name, it's returning something, it's returning a string, but our open level is looking for a name. There's some minor differences here, but we do need to convert it from one to the other. So just know that those are two different types technically, but if we plug it in, it'll automatically do our conversion. So at this point, we are waiting for our camera fade this amount of time, our respawn duration. We are getting the current level name and then opening that level. So our current level, we're reopening it. This should reload our current level. Hit compile, hit save, and let's test it out. Let's go over here, play, walk into the KillVolume. Okay, so the reason here is because we didn't really give it a very long duration. And the interesting thing is because over here, we click our variable, it defaults to 0, which is just, really, really short. Let's go over here and change this to something like 2. Let's give it a reasonable default, a little bit of reflection time for the player to think about where they messed up or what they did wrong. I always like to give a reasonable default, but if we wanted to change that, we could do this over here. If we double click the character, the designer could come over here and they could, if we look over here, we see in our defaults, the designer can come and we can change that if we like, or we could do that in the inspector, but I'm actually not leaving examples of my character in the scene. But if I did, we could actually change it down here if we want. I'm not going to do that. So I'm going to delete that character back out. We're going to spawn our character in and we're going to change it on the blueprint. So we just did that. Defaults to 2, but the designer could change it over here if you click on self if you want. Anyways, we have a 2-second respawn duration once the player dies. We'll compile, we'll save, We'll come back in, hit play. All right, now let's try it. Okay, 2-second duration. As soon as we hit the kill volume, it's done, we fade out, and then we respawn in. Okay, that's the basic functionality. Again, you could actually put this code on a custom player controller if you want, but I'm just trying to keep it all in one line, just so, simplicity, you can see this example, and then you can expand this out into your game as you like. But you could very easily, get the player controller and call a death sequence or a reload level if you reuse it on that, if you like. So anyways, that's how we reload the level. And at this point, our kill volume is pretty close. We just don't have a lot of feedback systems, which we'll handle next. So it's all functional, but we want to make sure that we trigger a sound effect and some kind of visual to let the player know that something happened. Right? So with the audio, I'm actually just going to pull some audio from the starter content, but if you don't see it here, you can always grab your own WAV file, just pull it in and trigger it the exact same way. I'm just using this because it's already created. And I'm going to do this inside of the player blueprint right here. I'm going to put my audio visual here. But you could have additional audio and additional visuals inside of your kill volume. So imagine that you have one kill volume that is a type of lava, right? You may want like a lava splash and lava goopy sound or something when the player dies. But I'm going to make a generic player death just to cover all my bases inside of this one place. But if you wanted specific sounds, you could call this, maybe you could expose this out and allow the designer to change out different kinds of sounds in the details panel. You could expose that, but I'm not going to deal with that. That would be a little bit more complicated. For now, I want the basic feedback systems on my player. When the player dies, I think it makes sense like right here. We're going to pull that out. When the player dies, so we do all our functionality, we hide the visibility. Let's trigger a sound effect and a basic burst particle. I'm going to hold Alt and I'm going to click on that node so that we disconnect that. I'm going to pull off of the set visibility node and I'm going to say spawn, I think it's called 2D. Yeah, spawn sound 2D. And that's just going to play a 2D sound to make sure that the player will always hear it. And this sound, if we select an asset, I'm just going to use the explosion sound from the starter content, but you could totally bring in your own. It doesn't really matter. We just want some kind of placeholder sound effect to communicate the information. Just make sure it's not too obnoxious, right? Explosion sound communicates a general idea. Don't make it very long and drawn out. So you can select whatever you want here. Explosion sound cue. Let's connect that to the camera fade. And we'll put the particle here once we set it up. Hit compile, save, come back in, hit play. Yeah, okay. That's fine for the audio. So now we want our visuals, and we're going to create a very simple burst with Niagara system. And I'm not going to put any time into this at all. We just really want the representation there. So all we really want is a burst effect with a certain kind of color, and that's pretty much it. Let's create a subfolder. We'll create a new folder. We'll call that FX. And inside of this folder, let's right click and create a Niagara system. New system from selected emitters. Hit next, select the, let's see, these might look a little different by the time that you're seeing this, but basically you just want a burst effect and that's pretty much it. We're going to do an omnidirectional burst. If this isn't an option, just look up a quick tutorial on how to do a burst effect. But that's all we're really looking for. Just make sure it somewhat communicates a burst somewhere. Omnidirectional burst. We're going to click that, hit the plus button, okay, and then hit finish. And we're going to call this FX_player_death. Okay, we'll save all, make sure that we save these. All right, so if we open that up, we want this to be really simple. For now, let's just change the particles to a slightly different color, and maybe we can scatter the sizes a little bit as well. Down here in initialize particle, we can hit spacebar to preview, or we can just hit the play button down here if we like. On initialize particle, let's change this to something that communicates that the player died. I think a red or an orange is pretty close. So we'll drag that over, hit OK. Again, we're being really, really rough with this. Sprite size. Now you could create your own custom material and whatever, which could override the color. But again, I just want this for placeholder. And then the effects artist can go and replace this later. I'm going to go to the uniform sprite size, and we'll just make that a little bit more varied. We'll say 1, and we'll say 12. I think it's fine. We can preview that. Yeah, it's fine. Potentially we could change the velocity to make that even more intense. Let's say 50 and I don't know, 800. Yeah, it looks a little bit better. Super basics. All we did is we changed the color, the size variation, and the velocity. And that's really all you need to communicate a simple idea. You could make this fancier if you go into Niagara tutorials, but I mean, that's a deep rabbit hole if you want to go down that path. So I'm going to save it. I'm going to come back, minimize. And all I really want to do is trigger this effect inside of our blueprint. So let's go back into our SS character and pull off of this, and we'll say spawn, I believe it's called system, spawn system at location underneath Niagara. So we're going to pull that in. We'll give ourselves some space there. Make sure we get it all. Okay. All right. So now we need to spawn this at a location. Now, one thing we can do is we can get the actor's current location. So right click and say get actor location. This will get the location of this character, like this actor that this blueprint node is attached to. So we'll compile save. This will give us the SS character's location. We're going to plug that directly into the location for where to spawn the system. So we'll spawn this at this character's location. We have disabled the visuals, so we won't see the character. We'll just instantly see a particle effect. And we'll spawn that in. We need to choose what system template we want. So our FX player death is totally fine. So we have that scale. We don't need to mess with that. We could if we want. Auto destroy when it's done. That's fine. Auto activate. That's fine. I think that'll do it. Let's compile and save. Potentially we could make this a variable and allow the designer to choose this, but we'll not mess with that for now. Compile, save, come back in, hit play. Once we load in. Okay, and that communicates a basic player death. So we have a visual, we have a sound effect, and we have the functionality there. So then the last thing we need to do is just clean up our code. And if we go back into our blueprint SS character, one thing that's pretty handy that you can do inside of a blueprint character is you can select a grouping of nodes. And as long as you don't have a delay node, which is a little bit more complicated, you can just collapse this into a function. Now, one thing you could do comments if you like, right? We did that over here. But this is a lot to look at, I think, and we want to pull this out into a smaller function over here. So let's select all of these nodes over here, and this is all related to disabling the player, I think, would be a good way to put that. And we'll select these nodes, right-click, and say, where is it? Collapse to function. Now, collapse to macro is a little bit different. We'll talk about that in a second. But if we collapse to function, we can give the function a name. We'll say disable player. And then we could rename this. Now this puts all of this functionality into a function that can be called, and we can actually call this other places, like from other blueprints on this character if we want. But what I'm doing is I'm isolating that into a separate function, kind of like how we'd refactor our code inside of a script. We'll compile, save, and if we want to see this, we can either double click it and it'll open up inside of a separate function window like that, or we could double click it over here instead of our functions drop down. I'm going to go back to my event graph in this little tab over here. This we could say, actually, we'll include the camera fade with that as well, I think. So this is all related to death visuals. We'll call this death effects, I think is a good name for this. So select the spawn 2D sound, spawn system, and start camera fade. Select all of this, right click, collapse to function, and we'll call this death effects. And actually, I don't like that name because I like my methods to have a verb to it. So we'll say rename. If you ever need to rename, that's how you can do it. And we'll call this play death effects like that. Pull that over. You see how much more condensed this is and readable. Pull this over. Now, the interesting one is whenever we have a delay node, our options are we can either have that as a macro, which is kind of like a grouping of nodes that can include a sequence. So we can delay, we can do multiple outputs, and we can do a lot of other things. Or we can just have the delay here, and then we could group this into a node. I think this is pretty succinct, but if we wanted to, we could right click and we could say collapse a function, or we could group all of this together and include the delay, and we could say collapse to macro. I'm just going to show you the macro version. So we'll include the delay here and we'll right click and we'll say collapse to macro. And that's what this looks like. And this is a little bit different. And it shows us that it has a delay associated. So we'll right click and rename. We'll call this death reload sequence. And that way, if we double click in here, we can see inputs. It'll just come straight in. It'll delay off of our variable amount, get current level name and reload it. And that's all we really need. Compile, save, go back to our event graph. And you can see how much cleaner this is and how much more reusable and readable. If we ever want to disable the player again somewhere, we could just call that function from somewhere else. It's the, don't repeat yourself style of coding, right? So macro, death effects, and then player function all over here. Pretty handy, pretty clean. We'll highlight all of this and hit C and say death sequence. Right. So when we call the died event, all of these things will happen. So I think everything is pretty clean. We can compile, save, and do one last test, but this is essentially how we can make a kill volume. Then we can repeat this and put it in our scene. Let's just test it out real quick. Then it reloads. Okay, awesome. And then, if I wanted to drag and drop my kill volume in other places, we could hold Alt, pull that out, rescale, make a little volume down here. Now in this case, we may drop, we may not. I don't know. Let's figure out. Let's see what happens. We'll save, hit play. All right, there you go. So it's reusable. It's modular. We can reasonably reuse this inside of our level. And that's about it. This is our kill volume sequence. And if you want to know how you can kill your player and reload, our lose condition, if you will, this is one way you could do that.